Back everyone. I hope you had a good lunch and get refreshed. We now kickstart our afternoon section. Before starts, we would like to invite you to participate in our lucky draw to receive the fabulous gifts sponsored by Microsoft, Red Hat, and Jack Spring. Simply fill in the online survey form during these 2 days events. You should see the survey link at this virtual conference room. Please refer to the guideline there to fill in the survey. We will announce the winner at our Facebook fan page at 19th of June. Now let me introduce the first speech in this afternoon session. The topic is City Big Data for Open Usage. It will be delivered by Eric Yao. Mr. Yao is the Senior Geospatial Manager of Ambit Geospatial Solution Limited, and he has over 19th year in geometric engineering, which includes projects using new generation of geospatial technology to support smart city development for the governmental and corporate enterprise. Let's invite Mr. Yao.
Hello everyone, I hope you have a good lunch today, and this is my sections. We start my So let me have a brief introductions of myself and our company. For Ambit, we are a city big data company. We use a cutting edge and highly automated approach to capture city information. And the approach that we are using manned helicopter, UAV, drone, or fixed wing, or even mobile mapping system, or backpack surveying systems. And here is a short video on showing how do we do our work. And in the city, we have a lot of geospatial or locational information that is very critical for smart city applications. So we are working out a new approach to effectively and highly automatically to capture our city information, including the vehicle, the MMS, the drone, or we will even use our manned helicopter to fly through the entire metropolitan city in order to capture the information in a highly effective way, and such that all the systematic information can be automatically processed and to be available to the city in a short period of time. And here what you are seeing is using a helicopter, and once we got all this information, we will post-process it in cloud-based software, and then we generate our new generation 3D city model, which is highly accurate and can be used for construction, planning, and even environmental applications. So a lot of our client is using our technology here in Hong Kong. Those are commercial corporate or even our local government. They're using this highly approach. And I believe all over the world and in every metropolitan city, they are using similar technology to capture the data. And this is one of our examples, CBD area in Hong Kong, which is next to our Victoria Harbour. And we capture these CBD area using our aerial capturing systems, and it will form a highly accurate 3D digital model in a 3cm resolutions. This is a project we finished nearly 3 years ago. And here is our patent technology used to capture the data. Although the technology itself is a patent technology, however, the post-processed informations all are open source format. They are mainly in OSGB format, Open Geospatial Tile format, or even in POT3 format. All these are open source format. There's plenty of viewer, which is a free in internet you can find to make, in order to make use of the data. And this is our patent technology. It is especially designed for metropolitan data capturing, especially designed for mount on helicopter. And this is one of the examples to showing you how effectively and how automated our way is for data capturing. For just one nearly two missions, in total of 6 hours, we can capture 110 kilometers square of data in a resolution of 6 centimeters. So you can imagine the efficiency to capture highly accurate data will be very quick. Here is another example that we make use to capture our data is by using drone. Some of the study area, they are very small. It's not cost effective to use manned helicopter. So we'll use drone. And because we fly very low, we develop our own autopilot system. And because fly low, we can create a high resolution data, much higher than fixed wing. And here is one of the example of the data. The area is very small. You talk about less than half kilometer square. However, the resolution can be nearly 1 centimeter. So it is very good for small area, ultra high resolution data capturing applications. And here is one of the building construction sites in Hong Kong that we make use of our drone to capture the data. And when we go back to the land, we capture data is not just necessary from aerial. We can capture data from terrestrial. And this is one of the mobile mapping system that we mount on a vehicle to drive along the road to capture the data. And here is some of the example of this kind of data. And this kind of data is through scanning. So it's come with a lot of point cloud information and come with the 3D panoramic information. And however, these information are calibrated information. So that means they can be used for measurement, for quantitative measurement. So you can measure the tree height or the roadside or the condition of the road. And all these are quantitative and highly reliable. So apart from using vehicle-based mobile mapping system, we also use backpack system. In some of the road in the city, it can be very narrow. So it is very difficult to use other mobile or vehicle-based system. So we will use our backpack system, which mount with a lightweight sensor, doing something similar to our vehicle-based data capturing. By using all these integrated approach, this is our target, to create a high-resolution digital map. People will say, how can we use this map? One of the immediate application and high potential application is to supporting the new generation autonomous driving. In order to be automated, you got to have a very good spatial database of the map of the road, the number of the road length, whether you can park and the road speed. All these road feature can be captured through this kind of automated approach. And all our data is in open format. Is in CTGML format, in portrait format, and in OSGB format. So all the third-party application can make use of these very rich album of the city to carry out their job to support their work. Here's one of the other applications, is we integrate our aerial and ground and terrestrial information to form a highly seamless three-dimensional digital model, such that user can view their city in a photorealistic way and even do the measurement of their city. For example, the road sign, the road structure, the road surface condition, all these are quantitative information you can extract from a digital model instead of spending a lot of effort to do site work inspections, which can take you several years. But for our application, it takes 1 week, and then we can capture several kilometer or even 100 kilometer of data, depends on the road traffic condition. And then the data is there. You can make use of this information in a very effective way to do your data capture. Here is another way that we foresee to carry on by using open data format. Once you get all the information, the next step is to do an auto feature extraction or change detection of the data. In order to do this, you need to have two conditions. First, you need to have a highly automated way to capture highly accurate data in a very quick way. Once you get the data, you can do this kind of data analysis. For example, the tree height, the tree canopy for tree management, or the road condition information. The system will be operated by AI algorithm, and they can auto-interpret our high-resolution data to work out the attribute of the city. Or even for land surveying, there's some road feature like the overhead cable or the lamppost, they keep changing. Or even the road width or the engineering design of the road. You can capture and analyze all these digital information from our high-resolution data sets, and then do other engineering or city planning applications. Here's another example for the lamppost and for the measurements of the road feature and even the tunnel features. So what we see, the open data application will be very large, and the technology itself already allows us to effectively and quickly acquire all this information. And the next step will be how can we make use of the data? And we believe that by using open data format, let the data available to as much of as much of a party as possible, such that the application and the potential usage can be enlarged very much. So that's our idea and our insights about the industry. And you are welcome to send us more information if you like to know more information about it. And I think for my sections of presentation, done.
Ma.
Hi guys, this is Akhil here. I'm the CTO and co-founder at Krunch. I'm just going to talk a little bit about how Krunch, as a data analytics platform, helps out community managers in the open source space. So Crunch, we specifically focus at collecting data on developers. And what we do is we collect that data from various platforms like GitHub, Slack. Hello? Yeah. From Slack, Reddit, and we pool this data in. And when it comes to helping community managers, we focus specifically on developer relationship advocates who focus predominantly on the developer community. So we specifically focus on a category of community managers right now, which is developer relationship advocates in the open source space. And what that does, it allows them to monitor their online community. So I'm going to talk a little bit about how we help developer relationship advocates understand their online community better, communicate with them better, and take good feedback back to their product and engineering team so they can improve the product. So we've been around for a year or so now. We've got a bunch of subscribers on our platform, right from Google to Red Hat. And that is because they find the analytics that we're doing quite useful. So let's jump to that. We're a little bit different to Hootsuite or Google Analytics in terms of how we analyze what the online community is saying at any given point. The key problem we felt that community managers face is, well, there are two key problems, right? So one is they will do some activity, be it an online blog or a YouTube video, and it's very difficult for them to understand in real time what is the community's reaction. And secondly, it's also difficult for them to measure their performance. So if they did a few events, a meetup, a Twitter microblogging, it's very difficult to understand their own performance, right? And they can take it back to the team and say, guys, this worked for me and this did not. So how currently it gets done is community managers will collect data from different platforms. They'll mostly set it up in Google Sheets or Excel. They'll plug the data there. They'll try and get through some analytics about their data, about their community, whatever data they're getting from online platforms like Twitter, GitHub, Twitch, Slack. And then they'll try and analyze whether the effort they're making is having the right impact in the community. Is the community growing? Is the community happy? So we said, okay, clearly there is something we can do from a data analytics viewpoint which can seriously help them out. So we created an online dashboard. Now, what it does is It collects data from a vast number of platforms. Like I said, GitHub, Reddit, Google Analytics, Slack, Twitter, Twitch, Hacker News. And when you come to Crunch's platform, we ask you to connect your, say, your GitHub account to Crunch or your Stack Overflow account to Crunch. And in real time, we'll fetch data from your Stack Overflow account, store it in our database. And first thing we do is we tag it with our tagging engine. So what that is basically is we identify the subject of each message that comes in and we tag it with that subject. Once we've tagged it, we get the data goes through three NLP engines. One is a question detection engine, one is an entity relationship engine, and the third one is sentiments engine. And this allows us to create some insights for the community managers about the community. So I'll talk a little bit more about those insights next. So first insight is, of course, tagging the data that is coming in. What that does, it makes it much easier for the user to search across all the platforms. Say if you are interested in, if you are a community manager for Python and you're interested to know what the community is talking about with regards to Python at any given moment, you just search for Python in our platform and we'll fetch you data across all the platforms where Python has been referred to and is relevant to you. The next thing we do on this data is that we carry out some sentiment analysis. Suppose there's a new Python library on which you've just done a YouTube video. We'll collect those comments and do a sentiment analysis on it, which is an instant indicator to you as a community manager whether the community is reacting positively, negatively, or the reaction is being neutral. If the community is reacting positively, then whatever you covered in your YouTube video clearly served the purpose. If the community is reacting negatively, it's likely maybe there is some misunderstanding, they're unsure, or they have further questions. If the community is neutral, then it's half and half. Some liked it, some are maybe still confused. Once we've done sentiment analysis and tagging, the thing we do is we do question detection. So on vast amounts of data that comes into our platform, we look at we look at a keyword that we're interested in, and we say these are the number of people asking questions right now around the subject of, say, Python, right? What are the questions your community is asking? So you can quickly pinpoint those questions and address them. Thirdly, we do entity relationship, which is effectively saying if Python is the keyword I'm interested in, I'm a community manager who's trying to grow the community around Python. What are the other things that people are interested in? Maybe it's to do with something to do with AWS and Python. So we'll understand what are the other topics that are being discussed with regards to your keywords. That gives you a quick insight to understand your community at a higher level. And what benefits does this bring to a DevRel or a community manager, right? So firstly, it's a single point of snapshot where you can see, where you can interact with all your data rather than having to go on individual platform. We fetch data periodically, so you don't have to get the data and plug it into your Excel and cleanse it. So we cleanse that. We give you instant positive or negative reactions on the strategies that you're trying to implement with your online community. That really allows you to stay in tune with your community at all times. In real time, you get to know what are the questions your community is asking. So you can quickly take those questions back to your product and engineering team and address them, right? So but by doing all these back-end tasks, we feel we help DevRels and community managers focus specifically on doing their primary job, which is to help their community to grow and address their queries, rather than get into the analytics of the community to understand the community better. And yeah, that's what we do at Crunch, I guess. Do you guys have any questions for me? Guys, are there any questions at all around Crunch, what we do, how we help out community managers in the open source space? Guys, is that it? Or are there any questions?